Again. Hello and welcome to the Daily Space for today, February 8th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. It is a beautifully sunny day here in the Midwest. I have sunlight trying to join me through my green screen. I apologize for the terrible green screening that is occurring. I'm going to work on trying to figure out how to fix that after this show is over. We are not here to discuss green screens, however. We are actually here to talk about all that is new in space and astronomy. And we have a whole lot of things going on today, a little bit of history, a little bit of science, and a whole lot of everything in between. Our first story is actually a science story, and this is a tale of salty stars, or in this case, at least one star that decided it needed to fill its planetary disk with salt. In new observations coming to us from the Atacama Large Millimeter Array, astronomers studying all the different molecular lines in the star Orion Source 1 in the Orion Nebula discovered that there are, 1 sextillion kilograms of salt in this star's planetary disk. To give you a sense of how big that is, that's a 1 followed by 21 zeros. It's also equivalent to the amount of mass that is in all of the Earth's oceans. So imagine taking that amount of mass, spreading it out through a planetary disk, and it's still a lot of salt, but it's not a high density of salt. It turns out this salt is actually spread out over a distance of 30 astronomical units to 60 astronomical units out from the star. Our own Kuiper belt only goes out to about 55 AU, so this salty disk extends further than, our own solar system in a lot of ways chooses to extend. But where it's located and how massive it is part of what made the salt so observable. This is actually normal everyday table salt. This is sodium chloride and NaCl, and it's only one of many kinds of salts and molecules found in this particular planetary disk. It's just kind of the coolest one. There are actually 60 different sets of atomic lines found in the radio spectra captured by the Atacama Large Millimeter Array when they looked at this star. Astronomers are now busy figuring out what all those different lines, what these musical chords are, and what they represent. When molecules are excited by collisions, excited by getting hit with sunlight, they vibrate. And as they switch from one vibrational state to another, they give off light. And that light has a specific energy that corresponds to the difference between one vibrational state and another. Atoms do the same thing as electrons jump from one energy level to another. These colors of light are unique to each atom and molecule in the patterns they form. You can think of these as musical chords where each particular set of notes is unique to a specific chord. Now, here we have salts, we have other molecules, and what we have is the ability for scientists to figure out where it is that different molecules end up forming within a solar system. It also allows them to very carefully measure the temperature diversity across this solar nebula. Different molecules hit different vibrational states and give off different colors of light depending on what temperature they're at. By seeing all these different lines, they're able to say, aha, this line occurs at this temperature, this line occurs at this temperature, and get at, not just the chemical profile, but the temperature profile of this star. Now, we're still going to have to wait a little while before we understand what this all means, but for now, there are new observations for the theorists to try and deal with their theories. Now, moving along, we have, more interesting news. In this case, we're going to do spacecraft. And the first thing we have is SpaceX and their upcoming crewed missions into space. I'm going to actually say human missions because let's face it, when you say crewed mission, no one knows if you're saying CREWED or CRUED. So we're going to talk about the next upcoming human missions to space. If any of you were listening to this week's State of the Union address here in the United States, you would have heard news that America will return to space using its own rockets launched from American soil this year. That was not a reference to the Space Launch System. That was a reference to the somewhat delayed, but not terribly delayed, human return to flight with SpaceX. SpaceX is currently looking at, here's an image of them testing their launch boosters with their Dragon capsule at the top, and they're going to do demo flight 1 with an uncrewed Dragon capsule, hopefully around March 2nd, 2019. They're looking to do an in-flight abort test on June 2019. This is where they make sure that they can abort safely if something goes wrong. This is a very needed thing. We've not had to use it very often, but you may remember just back at the end of September, the Soyuz capsule had to actually abort on takeoff when something went wrong with their stage 2 engines. Following what we all expect to be a successful abort test, they hope to launch humans in July 2019. So if all goes well, this summer we're going to have, astronauts launching from U.S. soil once again, as we have one more nation, our nation, my nation, I don't know where all of you are from, my nation will hopefully get to return to human spaceflight from our own soil once again. This is just good because, if you think about it, when Soyuz had to abort, we weren't sure if they'd be able to get back to the space station quickly. You really want to have multiple ways to space. With Russia and the United States both able to launch, as well as China, although the U.S. Congress doesn't allow China to go to the International Space Station, it's the friendly skies of space with multiple people able to get there in multiple ways. Okay, so speaking of China, this image captured by the Lunar Reconnaissance Orbiter has in it the Chang'e spacecraft sitting on the far side of the moon. Now, if you're like me, it's like, pretty crater. I don't see a spacecraft. Even though there's these little teeny tiny arrows pointing at a single fleck of light in this image. If you can't see it, don't worry, you're not alone, and I can zoom in. That single bright speck, and let me switch over to showing the image only. This single bright speck, that is Chang'e. Now, if that is one of the least exciting space images you've ever seen, that's okay. I kind of agree with you. But it's still kind of cool that we are able to image spacecraft while orbiting and just confirm, hey, yeah, China did it. Just like other nations have been able to confirm, hey, U.S. did it, as they image our own landing sites. Now, continuing on our journey of exploration, I have a story coming to us this time from Europe. In the coming years, the European Space Agency is going to be launching their own Mars rover. They are looking at the same 2020 launch window that the United States is looking at for its next launch. And as of yesterday, this little spacecraft has a name. This is the Rosalind Franklin lander. Now, don't anyone go calling this the Rosie rover. Rosalind Franklin is the woman who discovered the structure of DNA. Unfortunately, her notes were used by Watson and Crick to publish the results with those two men, using them without her permission and going on to get the Nobel Prize. Well, it is now well understood and widely recognized that that work wasn't done by them. It was done by Franklin. And one of the more discouraging things about this particular story is that when Rosalind Franklin started talking about this, Watson came out and was like, I shall write a publication and I shall put the record straight. And, well, what he actually did was refer to her demeaningly as Rosie. So don't do like Watson did. Her name's Rosalind Franklin. And just like Cassini is named after someone who's a dude and you refer to it by the last name, Cassini, this is the Franklin lander. So say her name, Rosalind Franklin. Now Rosalind Franklin is someone that wasn't given the fullest of opportunities to live out her full scientific career. She actually died of ovarian cancer quite young, dying just at the age of 37. After the work that she had done for DNA, she went on to do work at Birkbeck, where she studied molecular structures of viruses. The team that she put together kept following up on her work even after her death. And one of the sadder footnotes to this is it was one of her team's members, Aaron Klug, who went on to win a Nobel Prize in chemistry in 1982 for, well, the work that she had started. So this is an amazing woman whose work aided in 3 different men getting Nobel Prizes. But now she gets to go to Mars, at least her name does, in one cute little rover. So, Rosalind Franklin, I wish you safe journeys. Now we have one more tale of history, and this is a tale of Skylab. On this day, 45 years ago, the last astronauts departed Skylab, the United States' first orbital space station. In fact, humanity's first orbital space station. They departed. This was a standard end to their scientific mission. They left behind packed up starter bags of food and supplies for the next group of astronauts they expected would follow them on their journey of orbital exploration and science. Unfortunately, when this occurred back in February of 1974, we were at this weird in-between state of we were working on the space shuttle, but it was behind schedule, and there really wasn't another way to get astronauts up into space. Now, at the time, it had been supposed that Skylab was going to be safe and be able to keep on orbiting well into the 80s, and that the space shuttle would be able to return, dock up with the space station, boost it into a higher orbit, and keep on doing the science. Unfortunately, those orbital calculations were based on measurements that weren't quite accurate of just how active the sun could be and just how that solar activity could affect our atmosphere and increase drag on this space station. It turns out that when our solar system is blasted with solar radiation, it actually bloats up, gets larger in radius, and this means that more atmospheric particles, which are very few at this altitude, but large enough in number to create drag on a spaceship, well, that number creating drag increases with solar activity. And this spacecraft was done in by solar activity. Eventually, very much before it was expected, it was realized that Skylab was going to come plunging down through Earth's atmosphere. Rather than making it all the way into the 80s, it instead decided that the 70s were enough. It was done. It was going to come down. And so late in the 1970s, what we had was the first ever, no matter how inadvertent, bombing of Australia. In July 1979, this really large spacecraft fell down through the atmosphere in a completely uncontrolled manner, and large chunks of it landed on Australia. We're sorry, Australia. We really do like you. We particularly like to use your location to communicate with spacecraft. We're sorry. So this was one of those things that was a huge and unexpected loss to NASA. There were still food oxygen, all sorts of supplies waiting to be used by astronauts, but it just wasn't to be. So that's what happened on this day 45 years ago today. And this is the news that is coming out today as we continue to explore our solar system. And that's really kind of the end of science that I have prepared for you today. So I am now going to take your news-related questions, and if you can please at me, CosmoQuest X in the chat, it will make it a whole lot easier for me to find those questions and answer them quickly. While you type them in, I just want to remind you that The Daily Space is a production of CosmoQuest, and we're a production in turn of the Planetary Science Institute working in collaboration with Youngstown State University. We bring you The Daily Space every Monday through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. We are here to bring you, well, most, if not sometimes all that is coming out of press releases in space and astronomy, and a little bit else besides. In addition to The Daily Space, this channel also brings you launches, landings, press conferences, office hours, and all sorts of other special events. Give us a follow and find out when we go live. We never know when that next rocket is going to take off to space, but we do know we're going to try and be here to bring it to you. We are here because of you. We are sustained through your subscriptions, and every bit really matters. Thank you so much for supporting us both in communicating science and in doing science. I'm so very grateful for all your subs, all your bits, and all your donations. So thank you for all of that, and thank you for supporting science. If you're someone who thinks space needs more funding, well, this is your chance to put it right. The money that you donate to this channel doesn't just support this channel. It supports a whole crew of people doing science. And you can hear, well, Eddie agrees and thinks you should donate. Anyways, that's it. I'm going to answer your questions. So let's see what is coming in today. And I apologize for the very loud dog in the background. Okay. So Larry Weird and Proud is saying, that salty nebula, do you think it's close into the stars? Do you think close in the star's light, it scrolled, will break the bonds and have ionic sodium and chlorine? I don't know. I just don't know. I suspect that even far out that's happening. Young stars are extremely energetic and much hotter than older stars. So quite likely. Okay, I'm going to scroll back and see if there were any earlier questions I missed. And I'm going to thank Lockster TV for gifting a sub to Astrobee London. Thank you so much, Lockster TV. Scrolling back. Scrolling. Okay, I think I got to the top of your questions. Here we go. So Hanny's Rover is asking, related to the crewed mission of SpaceX, are they going to the International Space Station? I'm actually not sure on that. This is one of those things that changes often enough that I haven't kept up because I don't trust the information to still be true when it occurs. I'll let you know about a week before launch exactly what they've confirmed is going to happen, just in case they change their mind. They have already announced the crew. We actually did an episode on that when it happened. I think it was about 6 months ago that they announced. Astro YYZ is saying, any thoughts on the Boeing crew capsule test scheduled for April? We will see. It's actually not one of the SLS planned launches that is currently slated to happen this year. So with that schedule being bumped forward, we'll just have to see. I'm so sorry for the dog. I suspect that there is a mailman that is being threatened currently. So Hanny's Ververp is asking, does Changi only work in the daytime? So that depends on whose daytime you're talking about. Changi only functions when it's being hit by sunlight. And the lunar day is actually about half of an Earth month. So when you think of how long it takes to go from full moon to new moon, that is going from noontime to midnight for one place on the moon. So Changi works during lunar day using its solar panels, but it's not restricted to our Earth's day. Let's see what else is going on. String Theory is asking, what was the distance between Chang'e and the satellite at the time of the shot? They didn't include that information in the page I was looking at. In general, LRO orbits a couple of dozen miles up, but that was clearly taken at an oblique angle where it was looking in sideways. So I'm not sure exactly what the distance was from the spacecraft. It was pretty great, but wasn't insanely great. Yeah, Hanny's Rover 37 was way too soon, especially for such an amazing scientist like Rosalind Franklin. So Hanny's Verp is asking, is the volume of Skylab comparable to ISS? I saw a video that looked like there was a lot of room in there. So Skylab was configured very differently from ISS. Skylab was actually designed to fit on top of a Saturn rocket, so it was allowed to have a pretty big radius. And that's what you see when you look at the videos, is this amazing large volume with this huge radius. When we look at the capsules for the International Space Station, the modules that are used by the United States are the ones that fit into the cargo bay of the space shuttle. And the space shuttle's cargo bay was only the size of a school bus. So that means that when you look at them, they have a smaller radius. Now, the overall volume of the International Space Station is much greater because it has multiple different modules all coupled together. Skylab, on the other hand, was just one really large module. If you have the opportunity, go visit the Smithsonian Air and Space Museum on the Mall in Washington, D.C. They actually have a full-scale, one-to-one mock-up of Skylab. And that's where you start to realize just how much smaller it is than today's International Space Station. So the individual module has a larger volume, but the sum of the International Space Station's modules, plural, is greater than the volume of Skylab. Scrolling further. So Hanny's Vorverp is asking, was anything recovered from the crash site of Skylab? So Skylab largely deteriorated as it came through the atmosphere, creating an amazing light display. However, some of the chunks did bomb Australia. There were some fairly large chunks recovered. Just do a Google image search. There's all sorts of cool images of stuff that basically fell in people's backyards, the outback, all sorts of various different places. We're sorry, Australia. We really are. I don't think that Saturn V was originally a fuel tank, but it was definitely built on the structure of a fuel tank. So they didn't launch a fuel tank and then build inside of it. That was actually plans that we originally had for building the International Space Station. But it's built on the same size structure as a fuel tank. Okay, let's scroll more. Veronica Cure is saying, I hope no one was injured by the debris of the International Space Station. No, we didn't actually injure anyone. We just hit the ground pretty hard with large chunks of metal. Let's see what else is being asked. So Larry Weird and Proud said, I already asked that one about the Salty Nebula. Fenring asks, can we estimate now the average size of other planetary disks and if it correlates with the size of the star? One of the stories that we covered a few months ago was ALMA, the Atacama Large Millimeter Array, is systematically collecting image after image of disk after disk after disk of solar systems in the process of forming. This is a new capacity that we haven't had for that long. And we're just starting to understand the full diversity of how planetary disks can form. At this point, we just don't have enough data to say this becomes this becomes this, but we're getting there. Give us a couple more years. Theorists should have theories that are actually trustworthy and tied to enough data that I can say we actually can, statistically with good assurance, say what size solar systems are compared to the stars they go around. One of the other things that plagues the study is we haven't looked at a lot of stars that aren't sun-like to look for planets. The first stars that we nailed hard with telescopes going, do you have a planet? Do you have a planet? Do you have a planet? These were all sun-like stars. Some were smaller, some were bigger, but not that much smaller and bigger. Since then, using Kepler, we've looked at a whole lot of small stars because those kind of are by numbers the most common stars. But we're only starting to look at the largest stars to look for solar systems. Since we've only been doing this since 1995, and planets can take a whole long time to go around their star, and we like to see the planets go around at least 3 times before we confirm, yes, that is a planet. We're not yet at the stage where we even have enough data to say what size solar systems there are in systems that we aren't measuring with Atacama. So it's going to take a whole lot of data to answer just how different are grown-up solar systems like our own from the early solar systems that we're seeing with Atacama. We might find one set of trends for stars in the process of forming and something completely different when we look at fully formed solar system. An eyes shut tight. Eyes shut tight. Thank you so much for the follow. Thank you. Okay, let's go see. So Henny's Vorverp is asking, can we expect Rosalind Franklin to be able to search for Mars biology? It will be doing biological experiments. So the answer is yes for small values of biologic sampling. Let's see. So Super Cowboy 75 is saying, have you heard about the Italian astronomers who discovered a new dwarf galaxy called Bedin 1? I was wondering if you knew anything about it. Is this the one that was recently found while they were looking at a globular cluster? I think it is. Yes, I having confirmed that I knew exactly which one you were talking about. So what was really cool about this is using the Hubble Space Telescope, a group of astronomers from Italy, as you point out, were looking at a globular cluster, an old group of stars that all formed at the same time that is orbiting collectively around the Milky Way galaxy. While they were looking at this system of stars, they noticed that there was this dense blob of stars in the background of what they were looking at. And upon further study, they realized that those background stars actually were a collection of stars in a dwarf spheroidal galaxy that is one of the older systems that we've now discovered. It was formed about 13 billion years ago. And so that's just cool. And what makes it even more cool is this is an isolated system of stars. So it hasn't been troubled or enriched or otherwise harassed. And galaxy harassment is a thing, that's a scientific term. It hasn't experienced any of those things through interactions with other galaxies. So it really is a fossil relic that allows us to look at the kinds of materials that went into forming early stars. Okay, so let's see what else we have. Something just scrolled by. Gravity is a bully. That is entirely true. Gravity is very much a bully. So Henny's Vorverp is asking, what leads to the chemical composition of planets? Are they all made of similar materials? So you can't have a salt planet. Just not quite enough salt is made up to make a planet. This one salty solar system we talked about, well, that sextillion kilograms of salt that it has, well, that's the amount of mass that's in the Earth's oceans. That's only the amount of mass that's in the Earth's oceans. And the Earth's oceans, compared to the total mass of the Earth, are really tiny. So you're not going to get a salty world. You may get a salt-crusted world, however. The chemical composition of solar systems, as near as we can tell, is influenced by how metal-rich the star that is at its center happens to be. If you go to a solar system that doesn't have a lot of heavy elements, you're not going to find planets with a lot of heavy elements. You're not going to find a lot of rocky worlds. If you go to a solar system like our own that is metal-rich, that is above average in how many heavy elements we have, you're going to get the rocky planets like ours, as well as the gas giants that we see in the outer solar system. So it's all tied together. We're still learning the details, however. So that's where we're at. Ceres does indeed have salt-encrusted sections, Larry, weird and proud. It really does. It turns out there are ice volcanoes on Ceres, and the fluid that is coming out of those ice volcanoes is extremely salty. Tensveta, thank you so much for the follow. Thank you. So I think we may be out of questions for today. Later on today, we are going to, at 3 p.m. Eastern, which is noon Pacific, 8 p.m. London time, we are going to be doing a live recording of Astronomy Cast over on YouTube. And you are all invited to join us for that. Today's topic is going to be Fritz Zwicky, his amazing observations, cranky personality, and dark matter, and how there is now, in memory of his amazing observations and not his crankiness, there is now a Zwicky transiting facility that is being used to look for the things that flicker, flare, and move in the sky. So tune in just a couple of hours, and we will be bringing you more science. Sunday, as often occurs, we are going to have our own Annie Wilson showing up at 1 p.m. Eastern, 10 a.m. Do you notice a similarity in the times? Showing up at the normal time on Sunday to bring you her Sunday Science Hour. I'm not sure exactly what she's going to be doing this week, but she is often doing image reduction and showing how we go from the black and white kind of bland images that come off of spacecraft to these visually amazing images that you see represented in planetariums and other places. So tune in Sunday and say hello to Annie and catch more science. So thank you all for being here today. I need more room in my brain too, Larry. Thank you, Trekker Kev, for the bits. Thank you so much. So I am going to roll the credits, and while I am doing that, I am going to look for someone to raid. If you have a science streamer that you know is currently online and you would like to suggest, I'm always open to suggestions. All I ask is they're scientifically rooted or science and tech, one of those kinds of things. Other than that, I hope I will see all of you in a few hours over on Astronomy Cast. Wherever you are in the world, have a fabulous morning, evening, afternoon, and hey, remember, February 19th, there's going to be an occultation of Ceres, so make your plans today. We'll be talking about that more on Monday. I'll see you later. Bye-bye.